students, we will do one more example, and this will be, I hope, last example, and most of the concepts I hope you guys will get by this example also. Previously we have dealt with the y load, we had a figure, and in this case there is only text in front of us. And when we have text in front of us, a good engineer should be able to imagine what is the real system, what are we talking about in this text. We should be able to draw it and should be able to solve it. So first of all, a balanced ABC sequence. So ABC sequence, or this is another way of calling it a positive sequence. We have a positive sequence. We have a Y connected source with a VAN equals to 100 angle 10 degrees. And our load is delta connected balance load, where 8 plus J4 is per phase. Calculate the phase and line currents at the load side. Now let's draw the load. We have, okay, let's first draw the source, because the sequence is being determined by the Y connected source. So this is the source, it is the Y connected source. This is A, this is B, this is C, and this is neutral. And the value of VAN equals to 110 volts. So for all the students who think that they can directly solve these questions without drawing three-phase system, they will be in a lot of trouble. And let's look at our delta load. What it is saying, it is 8 plus J4. So we know that when it is positive J, it is actually an inductor. But if you don't want to draw that inductor, you can just draw the famous rectangle. And this A, B, C. So you'll say, oh sir, here you have drawn B on the right side and here you have drawn on the left side, but you are talking about phase sequence. This B I have drawn here for simplification, because it is easy to join B with B, or you have to go like this. So I am making it simple for you. This is a positive sequence, and the source is important in determining the positive sequence. So from A to A this is, and from this is this. So I have previously, like I told you, in this case they have a Y load. So you have to calculate the phase and line currents at the load side. So let us first see what is the meaning of phase current at the load side. Current going through every load, this is one phase. So he wants this current IAB, he wants this current IBC, and he wants this current ICA. These are the phase currents. And what is the meaning of line current? Line is again line. This is line A, this is IA, this is line B, and this is line C. So these are the line currents. And as I've told you when I was revising the concepts, you should be clear. And you can see from here that this current IA gets divided here. There is a node here. It is not the same current as all of the current will not go through IAB. So these two currents cannot be equal. So IA is not equals to IAB. First of all, you should remember this thing. And the second thing is, then if they are not equal, what is the relationship? The relationship is under root 3 IAB with angle of minus 30 degrees. This is the relationship that should be clear in your mind. If you know IAB, if you know this, you can calculate all the line currents. Now the story unfolds and the question arises, okay sir, we know this thing. Now how to calculate IAB? IAB is the current across this phase. And if we know the voltage across this phase, that is VAB, we can calculate IAB. Now what is actually VAB? VAB is in reality the voltage between line A and line B. This is VAB. So if I can find this VAB, I can find IAB. If I can find IAB, I can find IA. How can I find IAB if I know VAB? Because VAB, this VAB is equals to, IAB equals to VAB over ZAB. So if I know this VAB, ZAB they have already given to me, I can easily calculate IAB. So first of all, what I should do is I should calculate VAB. I hope I am trying. This can be done very directly, but the concept behind it should be very clear if you don't want to make mistakes. So let's see, by solving this, how can we calculate VAB? Just a second, students. Yes, so our question is now, okay. So Z delta or our ZAB, how can we calculate this? This is given, and the value of this is 8 plus J4, and this will be equals to 8.944, and the angle is 26.57. Okay, ohms. This is ZAB. Now we have ZAB. We have to calculate VAB. VAB can be calculated very simply. VAB, we have the phase voltage under root 3 VAN and plus 30. So what is the value of VAN? This value, this we are already given, that the value of VAN is 100 volts with the angle of 10 degrees. So this will become, VAB will then become under root 3 into 100, and for our angle 10 plus 30. So VAB is equals to 173.2 volts with an angle of 40 degrees. So this is our VAB, and so let's calculate IAB now. IAB will be 173.2 volts angle 40 degrees divided by 8.944 ohms angle 26.57 degrees. So IAB will become 19.36 with angle 13.43 amp. Wait, 36 amps angle 13.43 degrees. Now you have calculated IAB. You can calculate IBC. What will happen? We'll add minus 120 degrees, 106.57 degrees. And what will be ICA? 19.36. We'll add 120. This will become 1, add plus 120 to this one, 133.43 degrees. So this is how we have calculated what? The phase currents. And now to calculate the line currents, line currents formula, you know, these are the phase currents. Now to calculate the line currents, we know that IA, which is one is IA, the current, this one. IA is not equals to IAB, but there is a relationship that I have discussed previously. IA equals to under root 3 IAB with an angle of minus 30 degrees. So this will become IA equals to under root 3. What was IAB? And we had 19.36 and the angle was 13.43 minus 30 degrees. So IA will become 33.53 amperes and angle will be minus 16.57 degrees. Similarly, now you know IB, just do the magic of minus 120 plus 120 and you will get the other vectors. And we will have IC equals to 33.53. We will be having 1.03.43. So this is how this can be done. Now the question ends here. We have calculated the line currents and we have calculated the phase currents. So let's do one more thing. Let's try to draw the phasors. And what I'll do is I'll bring this here. And let's try to draw the phasor diagram of this. And let's look at this. So let's first draw the phasors of IAB. Let's take this as the reference. So these are the phase currents. Remember, it is a delta load. This is the line currents. They are not same. So for our IAB, it will be like this. This is IAB. This is 13.43. Now the next will be 106.57. So from here, the angle will be like this. This is IBC and this is 133. So this will be like this. This angle again from 0 is 133.43. This is ICA. Now let's draw the line currents. From the line currents, the first angle of the line current is minus, then again this dotted line is the reference. From that reference I am taking minus 16. Okay, and here is IA, and oh, what a big arrow I have made. From IB is minus 136. Okay, and it is something around here, and the other one, this is IA, IB, and this you can imagine is IC. So this is how I have made the phasor diagram. So I hope and let's see if students are having problem. I hope the angles, you guys are able to know the angle. This angle is minus 106.57. Roughly I've done this. And this this angle from here. And The angle from this to this point, I'm talking about ICIC, is 133.43. The angle between all the vectors, the angle between all the vectors from this to this is 120. From this to this is 120. But from the reference, I'm saying, I'm writing these numbers, and reference is at always 0 degrees. So students, I hope this is clear. Best of luck.